Assalamualaikum. Myself S.Rekha, Assistant Professor, Department of Mathematics. Today I am going to explain about the discrete and optimization technique. My topic is about the relations and types. So relations and types that today we are going to discuss about the binary relation. So binary relation is nothing but a relation between from a set x to y and also a subset of the students of an Cartesian product x cross y. If the ordered pair of G is reversed, the relation also changes, and the normally binary relation can be expressed as an A is a subset A cross A. There are two distinct sets, let us consider. One is A and B having a cardinality M and N. The maximum cardinality of a relation is nothing but M into N. So notification is nothing but one of the values related to one another. We call this a binary relation as X or Y. So for example, if you consider a pair of ordered pair of 2, 4, 3, 6 means we can say that 2 is related to Y, 2 is related to 4 and 3 is related to 6. So based on the concept we can discuss the binary relation. So if you have the relation between the two sets, then we can say it is a binary relation. Next is nothing but we are defining what is meant by Cartesian product. So Cartesian product is nothing but A equal to 2, 3, 5, B equal to 4, 6, 7. So we are going to cross the two product. So how to apply that? We have to take the 2 and we have to combine it with 4. Then 2, 4, 2, 6, 2, 9. Like that you have to write. Then 3, 4, 3, 6, 3, 5, 4, 6, 5, 6, 5, 9. We have to write that. So these are the Cartesian product. Based on the binary relation, we can say it may be a multiples of the 2 or also multiples of the 3, means we can express it as in the form of a relation. So we have a different types of relations are there. One is reflexive, symmetric, transitive. So what is meant by reflexive means? Reflexive is nothing but A is related to A, means we can say it is a reflexive. So reflexive can be written as A, A. Then whereas the binary relation, they have a types of relation, reflexive, symmetric, transitive. So if it is reflexive means we can say it is an A related to R, that is nothing but an reflexive. And as well as what is meant by symmetric relation means symmetric relation is nothing but A related to B or else B related to A. We can say it is symmetric. Then similarly, it is represented as x equal to y or else y equal to A. So hence we can say it is a symmetric relation. Then we will go with the transitive relation. Transitive relation is nothing but A related to B, B related to C, or else we can say it is A related to C. So now we consider that 1, 2, 2, 3, 1, 3, there are the three types of relation. Means how will you apply the transitive means 1 should be related to 2, means 2 should be related to 3, means you have to combine this 2, you will get 1, 3 should be related. So this is nothing but a transitive. And if the relation satisfies all the reflexive, symmetric, transitive, means we can say it is an equivalence relation. So a relation satisfies the equivalence relation is said to be an transitive, reflexive and symmetric. Example 1, 2, 2, 2, 1, 2, 2, 1, 2, 3 and 1, 3, 3, 1 means here the equivalence relation we can say it satisfies the reflexive, symmetric and transitive. So like that we can apply all the three. So what are the binary relation? Binary relation is nothing but relating all the values. What is equivalence relation? It satisfies all three relation, reflexive, symmetric, transitive. So these are the equivalence relation. So based on the equivalence relation we can solve the problem. For example, x minus y is divisible by 3 means, so only find the, first of all we have to find the relation like that. How x minus y should be divisible by 3 means 1, 3. That is a 3, 3, 3, 1, 1. 1 minus 1 is 0. That is also divisible by 3. 3, 3, that is also divisible by 3. 3, 6 we can consider. 6, 3 we can consider. Like that we can find the relation. And in that relation, you can identify what are the reflexive concepts, what is the symmetric concept, what is the transitive concept. So these are the conditions we can apply and find the values for that. So easily we can apply the relation and we can find the concept for the equivalence relation also. So there are various problems which is divisible by 3 and divisible by 5. You can refer the it's in the recent book of discrete mathematics, and in that you have the relations topic, and the relation topic in the exercise problem you can go through that and solve the problem as an assignment. Okay, thank you.